Hello. Let's go through this question. Paper 1, time zone 2, May 2022, physics high level. Number 11. Water at room temperature is placed in a freezer. The specific heat capacity of water is twice the specific heat capacity of ice. Assume that thermal energy is transferred from the water at a constant rate. Which graph shows the variation with time of the temperature of the water? Okay, so in this question here, we need to recall certain concepts in thermal physics. The first thing that we need to remember, okay, this shape or general shape of this graph between the temperature T capital on the y-axis and the small t, which is time in second on the x-axis. So the general shape actually of these four choices are basically similar, right? I mean, you see some decrease in temperature with time. So obviously water is placed in freezer. So obviously the temperature will decrease in the freezer, and then until reaching a certain temperature, okay, which is basically the freezing point, and then water will be changed into ice from liquid to solid phase. But during the change in phase, the temperature is constant, so which is right. So all of the graphs here showing constant temperature at a certain period until the last molecule of liquid water is converted into solid water, which is ice, right? And then, of course, ice temperature will fall with time. But here we need to understand, okay, like how this temperature would fall with time compared to water. Okay. The second concept here, or the given information, is the specific heat capacity. So the national anthem of thermal physics, topic 3, Q equal MC delta T. I call it national anthem of thermal physics. Q equal MC, C small, delta T. Now, capital T here, it means what? It means temperature or absolute temperature in Kelvin. And Q is quantity of heat in Joule, right? Now, C is the specific heat capacity, right? And M is the mass, and obviously the mass here is the same, the same amount of water, was placed in the freezer, just, changed into ice. So the mass is the same. Okay. Now, there is here an important keyword. So I'm going to solve this question using two approaches: physics approach and math approach. You can think physics or you can think math, depends on how comfortable you are. Let's start physics. Okay. Now, physics, okay, anyway, the given here, the thermal energy is transferred at a constant rate. So energy, right, is transferred at a constant rate, right, to reduce the temperature, of both phases, liquid or water and ice, right? So if I think physics, I say, okay, what is the definition? Like you say, specific heat capacity of water. Let's say CW is equal to 2 times C ice. Okay. So now I need to think physics. Okay, what is the definition of specific heat capacity? When you look at this formula here, we can rearrange C, right, as Q over M delta T. So C is the amount of energy, right, or amount of heat energy required to raise or drop 1 kilogram of the substance by 1 degree Kelvin. So this is the definition of the specific heat capacity, right? So now if the specific heat capacity of water is twice the specific heat capacity of ice, it means what? It means we need more energy, right, to drop the temperature of water right, compared to ice, right? Which means the ice will drop faster, right? Or water will drop slower. So this is basically how you think physics here. Now, option A obviously is not right because the slope, like the first, like, the slopes are the same in the change in temperature, right, versus time. And C also is out. Why? Because also the slopes are the same. So we are between B and D because we have different specific heat capacity, right? And now after, I elaborate on the definition of specific heat capacity. So the answer here should be B. Why? Because the specific heat capacity of water will take gentle slope, more gentle slope compared to the slope of ice, the change in temperature versus time. Okay, so this is the first approach. I call it we think physics. Now, if you want to take the second approach also, you are welcome. So now let us now talk about the mathematical approach, how to approach this question mathematically. So I'm going to say, okay, now I see here energy transferred are the same at constant rate. Now, what is rate of energy transfer? Rate of energy transfer. Oh, that is power. Okay. So say Q over time, this is called rate, right? Rate means over time in physics. So Q over time, which is basically energy over time, which is mean power, right? So mathematics, I can say, okay, so I can say the power of water is going to be equal the power of ice, because this is what is given here, right? Assume the thermal energy is transferred from the water at a constant rate. Okay, so that means the power is the same. Now, it means what? It means QW over time is going to be Q ice over time, equal. Now, Q, we can apply the national anthem. So MCW delta T, MC delta T divided by time is equal to MC ice delta T divided by time. And we agreed that the mass should be the same. There's no change in mass. It's the same amount of water, as I said. So we can cancel M with M, right? And then you can say, okay, now you can actually use this information here. So you can replace C sub W, which is specific heat capacity of water, twice. We can say 2 times Ci times delta T, capital T over small t is equal to Ci delta T over T, right? Now, what we can say, so we can say we can actually cancel Ci with Ci, right? So you end up with, like, okay, let me just, rewrite it like, so this is delta T over T for ice. And this is basically for water, right? So ice here, so we can say delta T capital over small t is equal to twice, delta T over T for water, right? So this is for ice and this is for water, which means what? Which means the slope, the slope or gradient is delta Y over delta X. Now Y is capital T, X is small t. Yeah, so delta T over T is the slope, which means the gradient has to be greater for ice, right, compared to water. And that's confirmed the answer B, because here the gradient here, the line is steeper, which means has higher gradient compared to water. Okay, so these are the two different approaches. Actually, in general, you can use them to solve any paper one question. You can think physics, or sometimes it's easier to think math. It depends on how comfortable you are, in any, like in a certain part of the problem. Okay, I hope it was helpful. If you are an IB student and you see, if you think it is important for you, you may thing to subscribe in the channel. So in this case, you will be updated and you will find lots of useful and like videos for your program. Okay, so thanks again, and see you in further questions to be solved.